Good morning. Okay, so it's Friday and we're going to come and do another one of our proofs. And this is proof number 4, which is on page 74 of your notes. Page 74, you'll need to find to follow along. And this is a difference formula. The formula is cosine of A minus B. So the cosine of the difference between two angles can be written as cosine of A multiplied by cosine of B plus sine of A multiplied by sine of B. And what that means, if we look at a diagram here, is if I have an angle like this, a big angle A, all the way down like that, and a smaller angle B, then A minus B is this angle in here. So this is A minus B. And we want to find cosine of that angle and come up with this formula. So this formula is on page 14 of your log tables as well. And you can be asked to prove it. You need to be able to draw this diagram. So when you draw this diagram, you're going to, let me just get a pencil to do it to the side again. You're going to draw a unit circle. Sketch a circle, center at 0, 0, and you draw a triangle inside the unit circle like this with A minus B in here. A minus B must be in there. So again, B is the smaller angle here and A is the angle that comes all the way out to here. The radius of the circle is 1. So these lengths here are 1. You have O in the middle for the origin. And then we'll call these 2 points here P and Q. So P is a point on the unit circle where we've made the angle A to get to it. So the coordinates of the point P are cos A sine A. Q is a point on the unit circle where we've gone through the angle B to get to it. So the coordinates of Q are cos B sine B. So a quick summary of how we do this proof. The first thing is that we need to be able to draw this diagram. Draw the diagram. And you might make a few notes for yourselves when you're going over this about how you would remember to draw that diagram. A triangle inside the unit circle, gone through an angle B with A minus B in the middle here like this. Then we're going to use the distance formula to find this distance here, the distance from P to Q. But we're not just going to find P to Q, we're going to square it as well. So you remember the distance formula has a square root in it, and we're going to be squaring both sides to get rid of the square root. Then we also find P to Q squared another way. We use the cosine rule. So you remember the cosine rule allows us to find the side opposite an angle squared, and we square that side as well. So we use the cosine rule to find PQ squared as well. So we get the same answer with two different formulas, and we put these equal to each other. We equate these answers, and then we manipulate our formula, which just means moving things side to side, multiplying out brackets, etc. Manipulate your formula to get cosine of A minus B on one side equal to a whole bunch of stuff on the other side. So those are the 5 steps in this proof. Now let's go through it. So we've got the diagram. Make sure you understand how to draw that diagram yourselves. Put O in the middle here. And the first thing we're going to do is we're going to use the distance formula. The distance formula. P is cos A sine A. Q is cos B sine B. And I'm going to use my distance formula, which is that the distance from P to Q is the square root x2 minus x1 all squared plus y2 minus y1 all squared. This is x1, y1, and this is x2, y2. Okay, so we're going to fill into our distance formula, we're going to square both sides, and that's going to give us the first answer that we're looking for. It's actually a little bit neater if we change around our x1, y1, x2, y2. It doesn't make a huge difference. You will get the same answer, but this just makes the algebra a little bit easier. If we make this one x1, y1, and this one x2, y2. So it just makes things a bit easier. So when I'm filling into this formula here, this is step 2, we get that the distance from P to Q is the square root of x2 cos A minus x1 cos B. It's just that I want the A first, that's all. All squared plus sine A minus sine B. Okay, and I'm going to square both sides, so therefore PQ all squared is going to be, and let me square out my brackets as well. Square the first, cos squared A, square the last, cos squared B, double their product, minus 2 times cos A cos B. Then my second bracket, square the first, sine squared A, square the last, cos squared, sine squared B, sine squared B, and double their products, minus 2 sine A sine B. And we'll notice something, the 2 sine A sine B, 2 cos A cos B, it's looking similar to what I want in my answer up here. Cos squared A and sine squared A. If you remember the very first thing we proved, if you have cos squared and sine squared together, they will be equal to 1. So cos squared B and sine squared B, those guys go together as well, equal to 1. You can rearrange them to put them next to each other if you want, but you don't need to. It's enough to just indicate that they're equal to 1. So that means that PQ all squared is going to be 1 plus 1, 2, minus 2 cos A cos B, minus 2 sine A sine B. So this is the value for P squared, PQ squared from step 2. And we'll come back to that in a second. Okay, step 3 said that I need to use the cosine rule to find PQ squared. So the cosine rule says that A squared is equal to B squared plus C squared minus 2BC cos A, where what? A is the angle, bring this down for a second, A is the angle opposite the side that we're finding, opposite little a. So little a is going to be my PQ, and instead of cos of big A, little a is going to be my distance from P to Q, and instead of cos of A, I'm going to have, just lift this up a bit so we can see the diagram and my writing at the same time. Instead of cos of A, I'm going to have cos of A minus B, because that's the angle that's in here, A minus B. That's the angle in there. What are B and C? The other two sides of the triangle. So B is 1 and C is 1 because it's a unit circle. B is 1 and C is 1 because it's a unit circle. And what I get filling into my cosine rule formula, which we proved last week, is that PQ all squared, so the distance from PQ squared, because that's A squared, is equal to B squared plus C squared minus 2BC by cosine of the angle in between them. So let's tidy that up a little bit, and we get that the distance from P to Q squared is 1 squared plus 1 squared is 2 minus 2 cos A minus B. So that was a lot quicker than the distance formula way. Now, both of those are the same because they're both equal to the distance from P to Q squared. So for step 4, I said we must equate them. We must say that they're equal to each other. So for step 4, we say that 2 minus 2 cos A cos B minus 2 sine A sine B is equal to 2 minus 2 cos A minus B. Now, the first thing we'll do is divide across by 2. We're very, very close to what we're looking for here. And we get 1 minus cos A cos B minus sine A sine B equals 1 minus cosine of A minus B. And then bring this to this side and bring these guys to that side. What about the ones? Well, it doesn't really matter which side you bring them to because they're going to cancel out. So we bring this over to this side, so rearranging. Rearranging means move things to whatever side suits you. And we get cosine of A minus B. Let's leave the ones on this side. Plus 1 minus 1 equals cosine of A, cosine of B, plus sine of A, sine of B. The ones cancel, and we have our formula. Cosine of A minus B is cos A cos B plus sine A sine B as required, as we were asked for. And there's our proof. So step 5 was rearranging, manipulating our formula. Okay, that's what we were asked for, cosine of A minus B, cos A cos B plus sine A sine B. And that's what we wrote down in the last step. Okay, so you need to practice that. I'd say write it out maybe 3, 4, even 5 times. Make a little summary for yourself. You don't have to have the same summary as me. Make sure you can draw the diagram. And let me know if you have any questions about that proof. Thank you.